Hi everybody, welcome to this second video about the IECHost project. So this is the console with which actually I interact with the device connected to my 1541 and as you can see, since last time we had a look, quite a few things have changed, quite a few commands have been added. Let's start with an init command to initialize the disk. What this does, it prepares me for a number of other things I'm going to show today. The latest additions to this interface are the possibility of upload a server program to the drive, which then answers to a number of fast access commands that can be used. One of them is used to query the status of the server, and the server just answers with hello world through a fast 2-bit serial protocol. Another command is, before getting to that, let's have a look at the contents of the buffer. So this is what has been sent through the first 5 bytes for the memory execute command. That is part of that mh command. So some of the code gets uploaded and eventually gets executed with an me command. Let's have a look at the sector reading command that uses the fast bus access interface, the 2-bit serial protocol. So as you can see, the job is completely successful, which is a reminder of, well, it suggests that I'm using the DOS sector read function, and the 01 is the job return code for a successful job. And now let's have a look at the contents of the buffer again, and there you go, that's where track 18 sector 0 has been loaded, which contains the file table, the BAM, the disk label, and ID. Let's try another one, 18.1. Again, this is completed successfully. Contents of the buffer is the directory listing, or the start list of the directory list. The last command will take a while, but it's nice to have a look, and it uses the RTC module, which is this one with the battery, to actually count how many seconds it took for the operation to complete. And the operation I'm going to try is a whole disk dumping with an interleave value of 3. So as if you heard, the seek stage went all the way back to track 1, and it's now advancing steadily every 4 seconds, about something like that. About 5 seconds actually. This process would get interrupted halfway or wherever it is if any of the sector read commands returns a job error code different than 1. So in case of error I would know. As I'm not seeing any error message, it all means that all the sectors on all tracks are being read without issues at the moment. Takes about 3 minutes for a whole disk dumping. Actually, the contents of each sector are stored in the buffer we've seen before, but they're not at the moment. They're not transmitted anywhere. And as I said, the function I use to read sectors is the standard one that is within the disk operating system, which is also known to be quite slow. So that's the bottleneck here. If we were to count the steps, the stepper model would be 35 in total. Or whatever it needs to get from 1 to 35, which is probably, which means 34 in reality. But anyway, and that's the finish time then. So as I said, this is about 3 minutes at the moment, and the next big step I plan to do is to replace the call to standard DOS function with a way faster sector read that is not concerned with GCR decoding, or at least doesn't do it as slowly as the standard function does. That's about it. Thanks for watching. Bye!